Today we're going to take a look at independent events. So we're going to take a look at a few examples. Here's the first one. Kyla and Jonathan play a game of cards and a pair of dice. Points are awarded if a face card is showing when you draw a card and or when you roll a sum of 9 or greater on the dice. If you get one of those outcomes, you get 2 points. If you get both of those outcomes, you get 5 points. And if you get neither of those outcomes, you get no points. What's the probability of 0 points, 2 points, and 5 points? So what's the probability for 0 points is when those outcomes do not happen. And independent events, rolling a dice or die or a pair of dice or whatever you're rolling is separate from picking up a card. That's why the probabilities are independent. They don't affect one another. Okay? So what does it mean if probabilities are dependent? Well, here's one for you. If the probability of Malcolm working on his math project today after school is 0.75, and then the probability of him getting an A on the math project is, say, 80%. Those two probabilities are dependent on one another. In other words, if Malcolm doesn't come today after school, the probability of him doing well on the math project will go down. So those two probabilities are dependent on one another. One event affects the other. But rolling a single die or a pair of dice does not influence the probability of flipping a card. So, what's the probability of 0 points? Well, face card is showing. Face card is showing, so 0 points would be no face card. So no face card would be 40 out of 52 would be no face card. And we can multiply that by no sum of 9 or greater. Well, first off, how do we figure out sum of 9 or greater? Well, what I would do for that part is, and I would do one of these. I would look at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The sum of these two would be 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. So how many of those sums are 9 or greater? Well, there would be 10 of them. 10 out of 36 are 9 or greater, so therefore the complement of that would be 26 out of 36, and that would go here. Okay, so we can multiply those to figure out the probability. 40 times 26, 1040. 52 times 36, 1872. Remember I told you last week, you don't have to simplify a fraction. You could leave your answer like this and be out the door. You could be. You don't have to do anything here. If you simplify the fraction incorrectly, you can only lose marks. If you write it as a decimal, how many decimal places do you use? If you write it as a percent, how many decimal places do you use? 2. If you write it as a decimal and then a percent, how many decimal places does the percent need? 2. No matter what, it's always 2. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. So 1040 divided by 1872, if we write it as a decimal, is 0.55555. Another thing, except for money, more decimal places is always okay if they're rounded okay. So it's 0.555555555, which is 55.56%. Okay? That's the probability of getting 0 points. What's the probability of getting 2 points? Now, 2 points, understanding this, 2 points can happen two ways. Either getting the point on the card and not the dice, or getting the point on the dice and not the card. We have to look at both situations. So if you get the point on the card, that would be 12 out of 52, and you still wouldn't get the point on the dice, so that'd still be 26 out of 36. But the alternative can happen too. You might not get the point on the card, but you might get the point on the dice. And that's, so in other words, just so we're clear here, I'm going to label this. So this is point on the card, but not on the dice. This is not a point on the card, but a point on the dice. And in part A, it was no points on either one of them. Okay? So here we're looking at, we can do this two different ways. We can either get the point on the cards or the point on the dice. So we have to figure out those two multiplications and then add them together. So 12 times 26 is 312. 40 times 10 is 400. 52 times 36, we already found out what it was. It's 1872. So this is 712 over 1872, which works out to be, if we're writing it as a percent, 38.03%. When you add fractions, the denominator stays the same. Okay? So we get 38.03%. Now, if we look at this objectively, 55%, 38%, that's like 93%. It should, our answer for part C should be about 7%. You know, around 7%. And the math that we're going to do should verify that. So let's go ahead and find the probability that they get points, 5 points rather. And 5 points is when both favorable outcomes happen. In other words, it's the 12 out of 52 times 10 out of 36. In that case, it's 120 over 1872. And 120 divided by 1872 is, if we write it as a decimal, or a percent rather, 6.41%. Which works out beautifully. So there we go. That's the probability of both favorable outcomes happening at once. In other words, getting 5 points. Okay? Now, another example. Keston goes to meet Draw in Flin Flon to support the math teacher's vacation fund. He buys 10 tickets. There's 500 tickets sold, and there's 2 main prizes. After one prize is drawn, the winning ticket is returned to the drum with all the other tickets. What's the probability that he wins at least one prize? Now we can run through the different possibilities. He wins both prizes. He wins the first prize. He wins the second prize, and we can add those all up together. That's 3 separate calculations and then adding them together. And there's nothing wrong with doing that. But remember a little thing called the complement. The complement is the opposite of what we're looking for. So the opposite of winning at least one prize is what? Winning none. Winning nothing. So what's the probability of him winning nothing? And we'll subtract that from 100% or 1. So the probability of him winning, he's got 10 tickets out of 500. So the probability of him winning the first prize is 10 out of 500. But the tickets do get returned to the drum, so the probability of him winning the second time is 10 out of 500 as well. So this is the probability of him. Ooh, my bad. Probability, where if we want to find the probability of him winning nothing, so that means that one of the other 490 get drawn, and the same thing on the second draw, one of the other 490 get drawn, not Keston's. So this is the probability that he loses on both prizes. Now we want to find the complement of this, so we're going to take this and subtract it from 1, because that's going to give us the probability that he wins something. Now, 49 divided by 50, or 490 divided by 500, times itself is 0.9604. So what this tells us is then that we get 1 minus 0.9604, which is 0.0396, or 3.96%. That is the probability that he wins at least one prize. Okay? So he wins 10, he buys 10 tickets, and that gives him about a 4% chance of winning one of the 2 prizes. All right. So here's the homework. You're in your textbook, pages 360 to 363, numbers 1 to 19.